My name is Katie Mack, and I am the author of this book, The End of Everything, Astrophysically Speaking, which will be officially released on the day of this video. I know a lot of people received the book early for mysterious reasons, but this is the announcement day, the publication day video. And in this video, I will be answering some questions sent in by people who pre-ordered the book as part of the US pre-order campaign. So if you pre-ordered the book anywhere you are, thank you so much. I really appreciate the support. It means a lot to me, and it's just a wonderful thing to see so many people interested in reading what I wrote about the end of the universe. If you're not familiar with the book, it's about different ways the universe might end. So yeah, now I'm going to answer a few questions that people sent in. There were so many amazing questions, by the way, and I had to pick only 10. If I didn't get to your question, I'm really sorry. Thank you for sending them in. All right, let's get started. So the first question is from Kobe, and the question is, since the universe is expanding, what is it expanding into? This is a very common question in cosmology. We know the universe is expanding because we see galaxies getting farther apart from each other. What we don't know is if the universe extends forever or if there's any kind of boundary. And from what it looks like right now, we don't see evidence for a boundary. We don't see evidence for anything outside what we would call the universe. All we really know is that the spaces in the universe are getting larger. So it's really more that the universe is getting less dense than that it's expanding into anything. And when I say less dense, I mean that the matter in it is getting less dense. There's complicated ways of accounting for density in astrophysics. So the second question is from Scott, and the question is, what is your take on dimensions beyond our current ability to perceive? Okay, so we live in 3 dimensions of space and 1 dimension of time. According to Einstein, time can be thought of as a dimension, just like, forward, backward, left, right, up, down. So if you think of time as another dimension, then we live in a 4-dimensional space. Now, it's possible that there are other dimensions of space that we don't perceive. It's possible that there's some direction that one could conceivably move in space that's sort of perpendicular to all the directions we normally move in. We don't have evidence for that, but there are certain clues that point us in that direction, and I talk about this a lot in the book, the idea that it's possible that there are extra dimensions of space and gravity can leak into those, but we can't travel into those. We can't see those extra dimensions. And if those extra dimensions exist, there could be entire other universes out there across some higher dimensional space, existing in this larger space. This is something that we're still investigating. We don't know. And my take on it is that it's definitely something we should be thinking about. It's definitely something we should be testing, but we just don't know yet if there are higher dimensions of space. Even though there are some theories like string theory that require the idea of more dimensions of space for the math to work out. But we haven't proven string theory. We don't really know if that's how the universe works. So we're working on that. Okay, the third question from David is, what's your opinion on the speculation that we live in a simulation, and how could we test that hypothesis? So I think the tricky thing about the idea that we live in a simulation is what that would mean is that there are certain sort of rules that are hard-coded into how the universe works, and we and physics and everything in the universe would be interacting according to those rules. Now, that's not so different from just laws of physics existing and everything in the universe interacting according to laws of physics. So it's not clear that there would be any real observational consequence if we were, somehow a computer simulation versus just the universe. I mean, if the simulation is good enough that we see things interacting via reasonable rules, we don't have numerical errors showing up. I mean, every experiment we've done seems to fit pretty well with what the laws of physics as we know them predict. So I don't really know how you would be able to tell, and I don't really know that it would be useful to know, because if we do exist as a computer simulation, we kind of by definition can't do anything about that. We're just software. So I don't think unless there was a way to rewrite the code, like change the laws of physics from inside the universe, I don't think it really matters. And one way I think about this is, there's this idea of how do you know if something is really artificially intelligent? There's something called the Turing test, where if you have a conversation with that computer program and you can't tell that it's a computer program, then that sort of meets some criterion for it being actually intelligent. And I feel like the universe has passed the Turing tests. Like, we can't tell it's a simulation. If it is one, there's kind of no discernible, meaningful difference between the universe being a simulation and being governed by natural physical laws. Okay, next question is by Slay. The question is, which is your preferred way for everything to end, astrophysically speaking? So in the book, I cover 5 different ways the universe might end. There's the big crunch, the heat death, the big rip, vacuum decay, and some kind of bouncing cosmology. My favorite of those is vacuum decay, because the way that would work is somewhere in the universe there would be a quantum event that would create a bubble of a different kind of space, and that bubble would expand through the universe at about the speed of light and destroy everything in it. It's my preferred way to go for a couple of reasons. One is that the physics of it is very interesting, so it's something that is kind of predicted by our understanding of particle physics, but we don't know for sure if it can happen. Another reason I like it is because it would be very quick and painless, so you wouldn't see it coming, because if it's traveling at the speed of light, the light wouldn't get to you before the bubble did. If it's traveling at the speed of light, your nerve impulses don't travel that fast, so you wouldn't feel it. You kind of wouldn't notice. It would be very humane, very painless, and there would be no tragic aftermath. It would just be over. So that's my favorite. Even though I know it scares a lot of people, I should say we shouldn't worry about vacuum decay, but if you read the book, I go into that in a lot more detail. The next question by Dennis is, can you summarize how an individual would experience a flip to false vacuum state in our universe? So that's going connected to the previous question of, if vacuum decay happens, how would you experience it? Well, you kind of wouldn't, because you wouldn't feel it, you wouldn't see it coming. But what would happen to you is, as the bubble of false vacuum, the bubble of true vacuum, that's what it's called, this new kind of space that's formed, as the bubble of true vacuum hits you, first the bubble wall has some energy associated with it, so that would sort of incinerate whatever it hits. And then once the bubble wall passes over you, the physics inside the bubble, the way that particles interact with each other inside the bubble, is different from the way particles interact with each other outside the bubble. And so your molecules kind of wouldn't hang together anymore. Like, you wouldn't have the same kind of physics of, an electron orbiting the nucleus of an atom. And so your whole structure would cease to exist, basically. It would fall apart in some sense. And you're in a different kind of space now, and one where everything is in some sense heavier. And that means that all of the space inside the bubble would start collapsing gravitationally immediately. So it would sort of fall into a black hole, basically. So it would not be pleasant in that sense, but you wouldn't feel it. You wouldn't notice. So, it's gruesome, but totally painless. I don't know if that's reassuring or not. Okay, the next question is from Danielle. Has a question about the universe expanding away from us and the fact that there's black holes that are pulling things in, and then there's the universe expanding out. How do these things interact with each other? So this is something I talk about a lot in the book as well, the balance between gravitational things in the universe pulling everything together and the expansion of the universe sort of pushing everything apart. And that is the kind of balance we're talking about. In a universe where there's more stuff, more black holes, more dark matter, more galaxies, just more matter in the universe, you could have a situation where the universe's expansion could stop and turn around and everything could fall back together. But in our universe, the balance is such that there's not enough matter to stop the expansion, and there's actually this extra component, dark energy, which makes the expansion accelerate. And so the expansion of the universe keeps going and will not succumb to the gravitational pull of everything that's trying to slow down the expansion and stop it. So I talk more about that in the book, but as it happens, there is that sort of push and pull, but the expansion is winning, and it will almost certainly continue to win. Okay, next question. What part of the book was your favorite to write? This is from Catherine. So in each chapter about the end of the universe, so there's five chapters that are just about specific endings of the universe. And in each one, there's a bit where I talk about what it would look like or how it would be experienced. And those parts really are the most fun to write because it's dramatic, you know. I think that my favorite bit was in the Big Crunch chapter. So that's where the universe is expanding, and then the expansion at some point turns around and everything comes back together. Again, we think that's probably not going to happen because the expansion is probably going to win, but there are still scenarios where that turnaround could happen. That part was really fun to write because the way that everything gets destroyed in that scenario is very interesting. First, galaxies collide with each other and the stars get all mixed up in their orbits, and you have new stars forming from all the gas coming together. That's dramatic. That's cool. That would look really interesting. But then also all the radiation in the universe gets compressed as well as the universe is collapsing on itself. And that ends up making just space really hot, in some sense, really full of radiation. And that radiation, as it's compressing in a collapsing universe, starts getting so hot that it can ignite the surfaces of stars. And I find that just a fascinating concept. So writing that out, like figuring out what would happen, reading old papers about how that all works, that was really fun to write. And I think that was one of my favorite sort of scenes in the book, how everything ends in a big crunch. So yeah, I mean, there's a lot of things. I found the whole book fun to write, honestly. Like, I really enjoy writing about these topics and I enjoy digging into the physics of it. But those little dramatic bits were a lot of fun. Okay, next question is by Emily, and the question is, of all the things you know and have learned about space and the universe, what brings you the most joy and scares you the most about our whole universe? So I'll address the scared part first. I do sometimes find it scary that we live in a cosmos that has these, giant unstoppable forces. There are these forces that are bigger than us. There are these processes that happen in the cosmos all the time that we just have no control over. Nothing we can do about it, just happening around us. And we're sort of this little speck of dust in this giant cosmic ocean, and we are adrift. And that's kind of a scary thought. That we're so insignificant that we can't control everything. But the thing that brings me joy is kind of connected to that, which is that even though we are insignificant, even though we are this tiny speck of dust, we still have the ability to understand so much of the cosmos. Like we can look out into the distance in the universe and look back in time so far that we can see the leftover light from the Big Bang. And we can study that light and we can learn about how the universe has evolved over time, what it's made of, how it went from being a kind of a space full of plasma and this roiling hot plasma from the primordial soup around the time of the Big Bang, and how that expanded and made this big empty spaces and galaxies and clusters of galaxies and stars and planets. I just find it amazing how much we can know, and I find such joy in understanding that and understanding pieces of this, finding little bits of knowledge, and I tried to put a lot of those in the book, places where there's just some cool little fact or something we've learned about the cosmos that is counterintuitive and fascinating. So I love that aspect of cosmology, just finding those little things and how much we can really understand and how much we can see and study about the universe. I think that's just a very fulfilling thing, that even though we're utterly insignificant, we can learn so much about the universe. Okay, next question is by Marissa. And Marissa says, I'm considering officially declaring myself as an astrophysics major soon. I absolutely love astrophysics, but I can't help feel it's not my place. Do you have any advice regarding that? I do. So I think that astrophysics is for everyone. I think that a lot of times when we only think about a certain kind of person doing astronomy or physics or other kinds of sciences, it can make us think like, oh, I don't identify with that. A lot of people see TV shows where there's some kind of genius person, and they're always kind of a similar type, right? And I think that often leads us to think that if we're not that type of person, then we shouldn't be doing that field. We shouldn't be doing that kind of science or whatever. And I think that's a very wrong way of seeing things. I know that we've been kind of conditioned to think about it that way, and we've been conditioned to think that you have to be a super genius to do physics or astrophysics, and none of that's true. You know, what it takes to be successful in this field, at some level, luck. You know, I mean, not everybody has the same opportunities, obviously, but you know, there's a curiosity, there's a willingness to follow your interests, and I think that it's important to not kind of count yourself out if you're really interested in this topic. I think that we need a lot of different perspectives, a lot of different voices and backgrounds in science in order to have a really good view of what's happening and to get new insights into the universe. And, you know, as you go through your schooling, you know, sometimes you'll be in spaces that feel comfortable and sometimes you'll be in spaces that don't feel comfortable. And I understand if you don't want to be in spaces that don't feel comfortable. A lot of things that we in science already need to do to make these spaces more comfortable for everybody. But I definitely think that, you know, this is a more diverse field than you might imagine. We have lots of different kinds of people, lots of different perspectives, and we need more of these different perspectives, and we need more different kinds of people. And you don't have to be a specific type or think of yourself as a science person or a math person. You don't need to do any of that. If you're fascinated by the subject, you want to work on it, you want to discover things, and you have the opportunity to get involved, you know, I definitely think that you shouldn't count yourself out. You know, give it a shot, see how you like it, see if you enjoy thinking about those kinds of things. Doing that kind of work is definitely worth doing. I've had a great time in astrophysics, and I think that I would love it if more people could see themselves as astrophysics students or astrophysicists. Okay, the next question is from Angelica, who's 13. Who says, how will the end of everything change people's views on the universe? And in this case, the end of everything is in quotes. So I'm not sure if Angelica is talking about the book or the end of the universe. Thinking about the end of the cosmos, which is what the whole book is helping people to do, is a way to change your own perspective on where we fit into this bigger picture of the universe, where we fit into existence in general, which I know is a big idea, but this is a book about big ideas. And I think it's an opportunity to kind of step away from our everyday lives and think about ourselves in the context of this much, much bigger, much more uncontrollable, but fascinating and beautiful thing. And I think that's a wonderful thing to be able to do. And I think that if you do change that perspective a little bit, if you give yourself the permission to think about these really big topics, to step away from daily life and into this larger space, into this larger context, I think that can help you to kind of see your own life differently, see the meaning of life differently, the purpose of life differently, in a way that I think can be helpful. I think that if we think about ourselves in that context, we often can also see how we're all connected to each other, how we're, you know, sort of temporary beings on this beautiful world, and we need to take care of that world, and we need to take care of each other. I think it can be a very valuable experience. So I do hope that reading about these big destructive things is a way to think more about where we fit into the universe and how we should make the use of the time that we have here on Earth and here in the cosmos. So those are all the questions I have time for. Thank you again so much to everybody who sent in questions, to everybody who pre-ordered the book, to everybody who's going to order the book or to read it. I'm really excited to have it out there in the world, and I hope that you all enjoy asking these big questions and learning something about the cosmos.